So yesterday we were dealing with relative velocities along parallel lines. So yesterday, can you please close the door? And we did some calculations on that. So today we're going to be looking at the second aspect, which is the relative velocity along non-parallel lines. So guys, I'm going to be making this PowerPoint presentation available when I'm done with the class. That is what I normally do. So when I'm done with the module, then I will upload it for the portal for you guys to have access to it. So now you have the full class, of course, with the recording as well. So today we are going to be looking at this is a textbook. I'm not sure if you guys were online yesterday. You saw there is another textbook. This one is 2013. I think there is an updated one of this, the same author. If you check on Pelego, you should see it there on Pelego. It's MJJ. So that's actually the textbook that the department normally use to extract their questions from. So I prefer to use that textbook. Okay, so yesterday we were looking at relative velocities along parallel lines. So today we are going to be looking at relative velocity along non-parallel lines. So how do you determine the relative velocities in two dimensions? So as you can see here, um, this aspect can as well be referred to as relative velocity in two dimensions. So with this one is the parallel was the one that we did yesterday. Okay, so basically what we're going to be doing here is we're going to be looking at addition of vectors that are not parallel to each other. Some you might have to resolve them into vertical and horizontal components. I'm going to be showing you that. Okay, so you can see from that diagram there, we have a vector which is a velocity of A relative to B that is moving towards that direction. Of course, there is an angle here, but there is a way the angle are being determined. Of course, taking into consideration the four cardinal points, which is the north, south, west, and east. I did mention yesterday that there is actually a sign notation that is attached to each cardinal point. For the northern part is positive, this is positive, this is negative, and this is negative. I don't know if my slide is visible enough, but I can expand it. So when you are dealing with calculations on kinematics, you should take that into consideration. So I'm going to put it there, a positive sign, negative sign, negative sign. So we looked at some questions yesterday, and then we were shown how to consider the sign when we are doing calculations. Okay. How do you determine the velocity of A relative to B? So I'm just I will be going straight to what you need. When you have a system of this manner. Okay. So there is an equation here that I want you to write down in your notebook. So this is actually like a Pythagoras theorem formula. So if I want to arrange these forces, I'm going to arrange them in a way that they will look like this. So I have velocity of A relative to the ground on y-axis, and then I have velocity of B relative to the ground on x-axis. And then I'm going to have the hypotenuse here, which is the resultant velocity. So the resultant velocity is velocity of A relative to B. So if you want to determine the velocity of A relative to B, these are actual velocities. This is the actual velocity of B. This is the actual velocity of A. I want you to get the concept right. Now, with the actual velocity, probably B represents an object, a moving object, and A also represents another moving object that is moving in another direction. So now, when we have two objects that are moving in different directions, not parallel, how do you determine their relative velocities? There is a formula that you use. You can see from what is written here, this formula was actually gotten from what I said, the Pythagoras theorem. So the velocity of A relative to B is, you are going to use this formula to get that particular magnitude. Okay. Now, um, if you look at the formula, we have velocity of A relative to B on the x-axis and the velocity of A relative to B on y-axis. Now, if you have been asked to calculate the velocity of B relative to A, so now this is going to be square, so it's going to be velocity of B relative to A on the x-axis square plus velocity of B relative to A on y-axis square. So most of the time you have to consider the x and the y axis, whether it's at an angle. If it's at an angle, you have to resolve into vertical and horizontal component. Most of the time, this is how your formula will look like. Because of the fact that they are not parallel, they are at an angle. You have to consider the x and the y axis. Okay. How do you determine the direction? The direction is the angle. I'm going to be showing you something on how to label the angle. Now, you agree with me that you would have seen an answer written, possibly for some of you that were in the class last semester. You will see maybe an angle written in this format, not that you have the angle degree east, or you see maybe they write west, an angle degree maybe south. I'm not sure if you know how you can determine if it is west south or whether it is northeast. Okay, let me just show you something here very quickly. If you look at this four cardinal point here, if you have an angle, if you have a relative velocity in that direction, okay, now, and then the angle is here. This angle is considered. Now, the angle is touching east, right? So you're going to write this angle after you get this angle as what? Let me clean this. You're going to write this angle as east. It's red. You write it as east. You have your angle in north. Of course, you know this is northeast. But how do you know which one to write first? Whether it is north, the angle east, or whether it is east, the angle north. The same thing appears when you have a relative velocity or a resultant velocity in that direction, and then you consider the angle here, which is theta. Now the theta, let's say this is theta 1 and this is theta 2. So this one is theta 1. So for theta 2 is going to be what? South, because you can see that the angle is touching the southern direction. It's going to be south, theta 2 degree what? East. Just to show you how to write those angles, the direction. Okay. Now let's move on. So if you are being asked to determine the relative velocity and the direction, so I've shown you the formula to use, whether it is A relative to B or B relative to A. Of course, it's not parallel. And then they will ask you to determine the direction as well. So I've shown you the formula to use to determine the relative velocity and how to determine the direction and how to write it out. Of course, with this one here, we have, of course, we have the x and the y. Of course, this, if you have established this and this, of course, if you use the trig function, it has to give you tan. So you can see here that you will just substitute here and get your answer. Okay. I think you get more clarity when we solve some activities here. So this was the second one I was describing. that if it's the other way around, if you are to determine the velocity of B relative to A, of course, you have to consider the X and the Y direction because it is not parallel. And then after considering that, these velocities now will now need to be determined. So you can see for B relative to A on X axis, and then for B relative to A on Y axis. So now this this is actually the same thing as the previous formula, but if you look at that expression, they said relative velocity of A in respect of B respect to A, right? So you are going to determine the velocity of B relative to A on X axis plus velocity of B relative to A on Y axis. So with the velocity of B relative to A on X axis is going to be the velocity of B relative to the ground on X axis minus the velocity of A relative to the ground on X axis. It might be zero. You just substitute zero there. With the velocity of B relative to A on Y axis is going to be the velocity of B relative to the ground on Y axis minus the velocity of A relative to the ground on both Y axis. I want you to get that concept right. So after you've determined the X and the Y of the relative velocity of B to A, then you now substitute to get the actual resultant velocity or the relative velocity of B in reference to A. The same thing as the first equation as well. Okay, so that is what you need there. Let's look at activity. I said yesterday that I don't solve examples. I believe in solving questions. And when I'm solving questions in class, I always like my class to be interactive. So this is an activity for me and you. You understand? Just the way it was yesterday, it was quite an interactive class yesterday. I would have just copied the examples and just be explaining the solutions. But to me, it's not how it's supposed to be. Well, I know some students are used to that in maybe previous subjects. I don't know. Okay, let's look at this activity. Let's try and analyze this activity here. So they said an object A moving south at 12 what? 12 meters per second. Now let's sketch. Let's do some sketching here. This is the south. 12 what? Meters per second. They said it passed a point while object B is moving due east. So east. Now you see how you see that their direction is not parallel. So the velocity of B is in the eastern direction at what? 8 meters per second. This is just a simple question to explain the concept. Now, the first question says that you must determine the velocity of A relative to B and the direction. Now, the first thing you have to determine here. Okay, you can see here that these are actual velocities, A and B. So the first thing you have to determine here is, of course, you know that your velocity of A relative to B, of course, squared, is velocity of A relative to B x squared plus velocity of A relative to B on a y squared. We all know this equation. So now we need to get these actual velocities here. Velocity of A relative to B on x in the x and x direction and the y direction. So how do you get that? So before you write that down, I also want to do a quick analysis here. I'm going to write out, let me just write it out with another color here. So I'm going to write out the parameters. You see how it is written down. Okay, the velocity of B relative to the ground on x-axis is what? 8 meters per second. The velocity of B relative to the ground on y-axis is 0. Because B is moving in the what? The eastern direction. That is 0 meters per second. Now, the velocity of A relative to the ground on x-axis is also 0 as well. And the velocity of what? The velocity of A relative to the ground on y-axis is what? Is going to be minus what? Minus 12 meters per second. Now, take note that I said that there are signs that are attached to this 4 cardinal point, negative, negatives, going towards the southern direction. So these are the parameters that you are going to use to do your calculations. You understand now? Okay. So now let's try to determine this, and then we determine this, then we substitute to get our answer. Okay. So let's determine the velocity of A relative to B on X is the velocity of A relative to the ground on the x-axis minus velocity of B relative to the ground on the x-axis. Just the way I wrote it here. You see? Okay, so that's the equation that we're going to use to calculate that. Okay, so the velocity of A relative to B on x-axis. Now, what is the velocity of A relative to the ground on the x-axis? Let's check our parameters. It's 0, right? So this is going to be 0 minus the velocity of B relative to the ground on the x-axis is what? Is 8. So it's 0 minus 8. So this will give us what? Minus 8 what? Meters per second. Let's just leave it the way it is. Now let's determine the second one, which is the velocity of A relative to B. The y-axis is going to be velocity of A relative to the ground on y-axis minus velocity of B relative to the ground on the y-axis. So velocity of A relative to B on y-axis, let's check. A relative to the ground on y-axis is what? Is minus 12. So this is minus 12. Of course, this one, B doesn't have y direction, which is what? 0. Velocity of A relative to B on the y direction is going to be what? It's going to be minus 12 meters per second. So what you need to do here, now you now need to substitute those. Recall velocity of A relative to B squared is equals to velocity of A relative to B in the x-and direction plus square plus VABY squared. This is the original equation. So you now substitute VAB squared equals to, we've calculated those ones. For x is minus 8, you put the minus 8 there squared plus this one is what? Minus 12 squared. So VA relative to B squared, this is going to give us what? Or you can just rather give me the value of the velocity. So by just finding the square root of 14,42. 14,42 meters what? Per second. So that is the velocity of A relative to B. We've gotten that. That is your answer. Any questions from those online? Thank you. For the second part, let me just read from my textbook here. The direction. How do you determine the what? The direction. Now, I want you to look at something here. Now, with the direction, if you look at this, okay, Let me just do this here. Okay, we have, of course, we have the resultant velocity. We've already gotten that. Now, with that resultant velocity, we have the one on the x direction and the one on the y direction. Okay, so this is how we are now going to draw that. So the velocity of A relative to B on x is minus 8. So you start from here, you put the arrow here, that is minus 8. You can write it as 8 meters per second. The one on the y is what? It's minus 12. This is velocity of A relative to B on the y-axis, velocity of A relative to B on the x-axis. You see, now the resultant velocity is what we calculated to be what? 14 point what? 14.42. Now, how do you calculate the direction? You're going to use tan. You can see from the formula here. So it's going to be tan theta is going to be equals to 12 over 8. Now, I use 12 over 8 because I'm considering this as my angle. You can also consider this as your angle in relative to the 12 meters per second. So my angle there, because I've indicated there that my angle is relative to 8 meters per second. And if you use tan, because if this one forms a right angle triangle, the opposite is of course is 12. This broken line and this line are parallel to each other. So this is 12, and then the adjacent is what? Is 8 meters per second, isn't it? So what will now be your angle? Let me just squeeze that somewhere here. So it's going to be arctan, right? Arctan of what? 12 over 8. It's going to give us what? 56 point what? 309. Okay, let's say 31 degrees. Now, how do you write that based on what I taught you? Now, that this is going to be west. Can you see the angle is touching that direction? And then it's going to be what? South here. Now, if you had put the angle here, whatever angle that you get is going to be what? It's going to be a south west. So this front here is going to be south and this is going to be west. Because the angle is touching this. So that's why you have to consider this first is west 56.31 degrees south. Of course, this is southwest or west south. I don't know this direction. But this is how you write it. So that's the direction. Yes. Hmm? When it changed from east to west. Object B is moving due east. Now remember, these are actual velocities. This is velocity of A relative to B on x-axis. This is not the velocity of B. This is not the velocity of B and A. So what we have done here is that we have resolved the velocity of A relative to B on x and y axis, the relative velocity. So that is the reason why we got our direction in that, with that one I indicated with blue. So it's what I calculated here, the x-axis and the y-axis. So remember, this is talking to the what? To the relative velocity, which is the resultant velocity. So whatever that you got here, because I got negative, negative, that's the reason why I drew it in that direction. So that is how you get your direction. Okay, so I want you guys to try the second one, which is the one of B relative to A now. Can you try that? I'm just going to write out the formulas that you need. So you're going to be actually working towards this formula here. Remember, you are going to use these conditions here. What I wrote here, this one, and this one. North was, not what? Northeast. So what's the angle there? Well, you can consider any angle, whether it's this direction or whether it's this direction, depending. When you subtract this from 90, you get the other one, isn't it? You can see we got positive here, and then we got positive here. This is north, and this is east. Positive, positive. So whatever that you're going to get here, okay, let me just separate these angles. Theta 1, theta 2. Theta 1 is going to be north. Let me just write it in this way. Theta 2 is going to be east. So whichever angle that you get there, you are going to get the same. It's still going to be the same answer. Whether it's theta 1, you chose theta 1 or theta 2, it's still the same. The most important thing is this cardinal point, the first and the last one here. This is what will define your answer, even if your angles are different. Okay, let's look at question 2. This is also a typical exam question. Let's look at it together. The question says that car A is moving north. (70 kilometers per hour). Car B is moving 60 degrees west of north. Which direction is that? This is the west of north, isn't it? And this is the east of north. So the west of north, 60 degrees, right? Let me just, you're going to draw it like this. This is 60 degrees. 100. Let me just put something here. The first question, you have to calculate, of course, velocity of A relative to B, then the other one B relative to A. Now, let's define the conditions first, like the way we did here, the one I wrote in blue ink. After you've already gotten the actual velocities, then you can now use the formulas. Let's start with A. The velocity of A relative to the ground on the y direction is what? 70. Velocity of A relative to the ground on X is what? 0. Because they said it's moving directly north. And the northern direction is what? Positive. Let's look at B. Now, if you look at B there, you can see that it's at an angle, right? So it simply means that you have to resolve into vertical and horizontal components. Okay? We have the vertical component of B, and then we have the horizontal component of B. Let me just write this somewhere else. The vertical component is what? This is the velocity of B is going to be VB sine of theta, and then this is going to be VB cos theta degrees. Let me analyze this better. Let me put the straight line on a straight line here. Now, if you look at this right angle triangle here, I want to consider an angle here. And then if you draw something like this here, now, and then you draw something like this here. Now, this is 60 degrees, right? This is also going to be 60 degrees, isn't it? Alternate angles. If that is 60 degrees, the angle here is going to be what? 30, isn't it? This is 90 degrees. So the angle here is what? 30 degrees. Do you understand? Okay. So with the vertical, let me just write it here. The velocity of B relative to the ground on y-axis, that's the vertical component. So that is going to be VB sine of 30 degrees. Velocity of B relative to the ground on x-axis is going to be the velocity of B cosine of 30 degrees. I believe you know that sine 30 and cos 60 is the same. And cos 30 and sine 60 is the same. You can consider 60 degrees, you are still going to get the same answer. Do you understand? Okay, now let me just remove this cardinal point here. Okay, so let's substitute and let's get, now VB is 100, right? So this is 100 sine 30 is 100 cos 30 degrees. Can you give me the answer for the first one and the second one? Cos 30? 6.666 or just 0.660. Thank you. All right. So we have established those conditions. So now we are not going to use our normal formula to get our relative velocity. So they said we must determine the velocity of A relative to B. Of course, you write it considering X and Y because it will form a right angle triangle because it is not parallel. A relative to B on Y axis squared. Those formulas we were using, those are the formulas that you are going to use. So for the velocity of A relative to B on X axis is going to be velocity of A relative to the ground on X axis minus velocity of B relative to the ground on X axis. The one of velocity of A relative to B on Y is going to be velocity of A relative to the ground on Y axis minus velocity of A, the velocity of B relative to the ground on y-axis. So this is the first equation, and this is the the second one. This one is a constant one. So all, you just substitute all the parameters that we established into the equation, you get your answers. They said velocity and direction. Of course, still the same way, the same concept. Can you try that? So I think the main area here is the diagram and the datas. If your parameters and the diagram is wrong, even if you use the correct formula, you get a wrong answer. But if you can establish if your diagram is correct, your of course automatically your parameters will be correct. And then of course you just substitute inside the formulas. Yeah? I'm just gonna put the angle there. I don't know which one that you want to consider, but we know that it's northeast. Let's say you consider this one theta 1 or theta 2. So for theta 1 it's going to be what? It's going to be north, theta 1 east. So this is going to be east, theta 2 north. So depending on which right angle triangle that you want to consider, you want to use. If you want to use the one for theta 1, if you just close the right angle triangle here, you have your 90 degrees, and then this is 86.6. This will also going to be 86.6 because of the parallel line. And then with this one, because this is 20, if you want to consider this right angle triangle, if you close it here, this will also be what? 20 meters per second of the parallel forces. So whether you use, let me just label this. I want to use triangle A or triangle what? Triangle B. So triangle A is applicable to this, and then triangle B is applicable to the second value. Any question?